There's a great little piece of advice that basically says, if you're going to do a demonstration, don't say anything more predictive than watch this. Ma'am, what is your name? Marilyn? I asked for your name so that I could do this live and sort of kind of convince people that I wasn't just running a pre-compiled program.
I saw you talking to her in the parking lot.
Mom! Alright. Anyway, of course, there's always the sneaking suspicion that there's some Wi-Fi trickery going on next to Jesus. Thanks a lot. But no, this is actually a propeller-based spin compiler. The name of my program system is Sphinx, and it's a self-hosted spin compiler system. And if you kind of squint your eyes and look at self-hosted spin compiler system, you can sort of see where Sphinx might have come from. It requires some hardware. It requires a propeller system that has an SD card attached to it. It has an NTSC display, or TV, and a keyboard. It can be more than that with Maryland. It can compile, for example, the object exchange, the TV driver, the graphics driver, the graphics demo, and most importantly for me was that in order to call it self-hosting, I had to wait until it actually compile itself, which I can't. I had written a PC-based spin compiler called Sphinx, and so I had some experience writing spin compilers. And I was curious to see if writing one on the propeller was even possible. Let us look at the structure of a typical hello world kind of program. We have a top object, hello, which is a sub-object, TV text. And TV text in turn has a sub-object, TV. Now when a PC-based spin compiler starts to compile hello, when it hits the OBJ section and sees that it has to read in TV text, it then reads in TV text and starts compiling it. And then it finds out it has to read in TV, so it compiles that as well. So ultimately, the PC compiler is compiling 3 programs together. And compiling is kind of expensive in terms of memory and time. So I realized that I couldn't follow this model in terms of compiling propeller. So I've gone back to a more traditional compile and link model. And now I'll be kind of making a distinction between the compiler and the linker. The compiler translates one spin file into one object file. And the object file I'm calling SOB, spin object binary. A SOB file contains the actual executable bytecode for the methods in the object. But it also contains a list of the object's export, and it also contains a list of imports to the object's sub-objects. The SOB is actually a compiled version of an object. So you can think of an object as existing either as spin source or as SOB. So when we send hello.spin into the compiler, at some point it will need some information about TV text, because hello has that sub-object TV text. When the compiler needs that information, it reads tvtext.sob, not .spin. So it doesn't have to actually compile TV text. That's the way it's going to be. You have to compile sub-objects before you compile the objects that are in it. So back to this object tree, that means that you compile from the bottom up. You compile TV, that gives you tv.sob. That lets you compile TV text, that gives you tvtext.sob. And you can compile hello.sob. Once you have hello.sob, you have to somehow transform the SOB file into an executable bin file. And that's where the linker comes in. The linker reads the bytecode, and it also reads the imports for this object. Imports being this sub-object. Finds out it needs the sub-object TV text. So then it goes out and reads TV text, and gets that objects, bytecodes, and imports. And of course, TV text has a sub-object, TV. So now the linker has read 3 SOB files, and that's all it needs. And now it does its linking magic, where it figures out how various objects are going to be laid out in memory, adjusts the pointers, and then it writes it all out, an executable binary image to hello.bin. That's it. That's how Sphinx compiles a program.
Sphinx kind of reserves 5 cogs for its own purposes. One is driving the text output on the TV, and there's a keyboard driver that lives in a cog, and then there are 3 cogs dedicated to the SD card system. And the other 2 cogs are implementing a very primitive, bare bones FAT16 file system. All you can really do is read a file, or write a file, or execute a file. So it does take up about a half a K of memory at the top of RAM. Most of that is a buffer for metadata. And then there's a few longs to communicate with the different cogs. So Sphinx consists of these 4 core programs: the lexer, the code generator, the linker, and then Sphinx.bin, which is the program that installs those drivers into the various cogs. The cogs remain running even as the hub program itself gets swapped out, so that you start up Sphinx and it starts these cogs running the keyboard, TV, and the SD card stuff. And in the hub, you have the Sphinx program itself running as a small command line shell. And then you type a command into the shell. Sphinx doesn't really have any built-in commands, it just launches programs that you type in. So you type in dir, and it goes and reads the dir program into hub memory. The dir starts running. The dir communicates through those cog routines to do the keyboard, video, file system stuff. And then when it's done, it loads Sphinx again, and we're back to the command prompt. So it looks kind of like there's an operating system on it, but it's not real. It's all smoke and mirrors. I guess I should talk a little bit about practicality. It's not really, at this point, practical to develop full-blown spin programs on the prompt. Right now, I think the limiting factor is actually the editor. The compiler itself can compile real programs, as you saw, but it's not really designed to compile. It's not really designed to be a replacement for the prompt tool. And even though Sphinx can compile itself, I can't claim that Sphinx was developed in Sphinx because the editor is not up to it. The source files are too big for the editor for that. So if you're interested and want to check it out, download it, I have a website under construction, Sphinx, www.sphinxcompiler.com. I guess that's it. Enjoy the rest of the expo. Thanks again for